Greetings to everyone. Today we're going to present the project the Smart Plant Communication and Management. The title is Emoji-Based Interaction System through Real-Time Sensor Feedback. Team members includes my partner Pubi, me, and Romit.
Yeah. So this project mainly focuses on hydroponics, and we all know that agriculture is one of the crucial backbones of human society, and hydroponics is one of the most advanced system we have in terms of controlling plant growth. Even though it is more advanced and it is very prevalent, it still has a lot of drawbacks, which is what we are focusing in this particular project. So the drawbacks that we are noticing at this moment is we are very reliant on human monitoring and adjustments in terms of all the hydroponic systems which are controlled by us, which means it is going to be time consuming as a first drawback, as well as it leaves a lot of error in terms of human errors that are possible in the system. So it requires a very high threshold of like expertise in terms of the hydroponics. So only experts can um, control and monitor the systems, which is a drawback by itself. So the main factors we are noticing here is time consumption and then human errors. And on top of that, um, we aim to make the system more simpler and have even beginners like non-intimidating with the monitoring and controlling of plants that we want to grow. So that is the aim of the project.
So you may say, how we can solve this problem? One possible solution that we choose is to integrate an advanced sensor technology that will tell the owner through emojis how the plant behaves, how the plant feels, and also an implementation of an automatic system of watering and lighting will be beneficial to make it easier for the owners to take care of their plants. That will allow users to quickly assess the conditions without having to carry it every time and be present at certain times. So these real time alerts will be crucial for them to encourage them to get more plant species.
So the components we are using in the system is basically a bunch of sensors and then a part of actuators which react to the readings that we get in the sensors. The main components are light intensity sensor, soil moisture sensor, analog temperature sensor, and then a grow lined water pump and a OLED display to display all of the results to the user. The main use of these sensors is that the light intensity sensor gets the surrounding ambient lighting, which the plant has access to. So this sensor helps us be in touch with the amount of light the plant is getting. So we can be sure that if the plant needs more sunlight, we can do something about it. Similarly, for soil moisture sensor, it collects real-time data about the soil's current moisture level. So we have access to um, the water level of the soil that the plant lives in. So based on a plant, we can change the setting of the moisture sensor, and we have different thresholds which we can use to trigger water um, using the horizontal pump. And then the temperature sensor monitors the temperature of the soil and the ambient temperature of the air. Similarly, the grow light and the horizontal pump is used to make action. So grow light we can use to react to the light intensity sensors readings, and horizontal pump, like I said before, can be used to supply water for the system. And OLED display is to display all of these to the user in an easily compact way.
About the wire diagram, and this diagram represents a smart plant communication and management system where we use SP3, SP32 that will control and will manage all the systems and all the components that are built in that circuit. To make that possible, we use the microcontroller that will be useful to not only provide the data or the signal, but also to provide with energy and with energy source and also the pin ground. Also, we use the MOSFET as part of a temperature sensor, LDR sensor, with along with a resistor of 1 kA to reduce its noise, and also the temperature, the soil moisture sensor to measure the current state of the plant. And them all will be all connected and linked to the ISP microcontroller, and they all will send data to it about the LD, and not only about the power supply. We also use a clock pin and data pin to provide the interface and the current state of the plant.
And regarding the program we use to design the system, we have three parts in the code, where in one part we mainly get all the sensor data, um, which from the soil moisture sensor and light sensor and the um, temperature sensor, and all these data are used to perform actions in our system. So based on the threshold we set for our current plant, this data that we fetch from the get methods are used, and this data are then passed on to the next stage of the code where we are performing actions. So based on the profile we have for our plant, we will be performing different actions. We'll be at different levels, we'll be supplying water and adjusting the light in our grow light. And apart from this, apart from the actions that we do, we are also displaying this particular real-time data for the user to see in the display and also in the blink interface, so that the user can also stay updated like in real time.
So for the demonstration, we have two images in which we can see how the system works. We built the prototype to see what will happen and how the code will run, and all the conditionals will demonstrate the different kind of states. For example, on the first screen, we can see that as the soil moisture is not connected or is not grounded in a soil, it will it will tell that the plant is sad. It will tell that the plant is not going good because it's not measuring anything. So, and in contrast, in the second screen, we can see that the plant is feeling good. It's okay. It's due to the it's due because the plant that was used is now feeling okay according to the parameters given, and it also accomplished with our main goal that we are seeking for. And also we demonstrate all the processes through through a simulation, and also a recording of a video in which we can see how the system works depending of how the state of the sensor changed. Not always not only in the cell measure sensor, but for example in temperature measurements, and also for the light sensor, when it reaches 0% on, also for temperature it goes under -degrees, so it will all change depending on that.
Blink cloud interface, the user gets to have real-time updates on the plant's health, as well as the temperature, light, and moisture levels of the plant system, and also if the grow light is currently on or not, and also the valve control. So a potential improvement on this system could be that there is plans to implement an override and have the user take control of the grow light as well as the water supply, so that the user can water the plant at will wherever they are, irrespective of being in person with the plant.
In conclusion, according to what we seen from the test and from the simulations, we can say that the system successfully facilitates the plant care by offering an interactive, intuitive platform. It is because the OLED and the interface provides a better understanding of how the plant, what's the plan, the mood of the plant. Also, by enabling time preventive or immediate actions, it not only simplifies plant management, but also encourages plant cultivation among users, potentially attracting new enthusiasts and clients. That's very important because that's the aim of the principal aim of this in this project, which wants to make more people go green and also care more about plants, and also how they can feel. It's not always to take care of them and get rid when you get the fruits or you get the goods from it. And also they use emojing to compare plant action conditions further enhances user engagement, bringing a gap between technology and everyday plant care, as well as, for example, other implementations of pet virtual pets as Tamagotchis. So that's very it's a new way to see how to interact, how to communicate, and how to care different organisms that we didn't think about that before.
Thank you so much for listening to our presentation. We really appreciate your take.